So, hello. My name is Nate Bade. I'm the program director for the MSc in Applied Mathematics at Northeastern University, and my specialty is sort of in the machine learning data science world. So today I'm going to talk to you guys a little bit about why we should construct features by hand. So, given all of these machine learning tools and everything, what do we get out of bringing some prior knowledge into data analysis? So kind of where we would be at in the class at this point is we would have already done some exploratory analysis, already done some data cleaning, and already done linear regression and multilinear regression. So the kind of project we might be coming off of would have been something like looking at some of the, one of the medical data sets and showing that you can, for instance, you can drop ethnicity and completely recover it based on things like pricing information and diagnostics. Not completely, but with about an 85% success rate. So, that is very, so that's where we'd be kind of starting from. In this lesson, we're going to look at the Airbnb data set for New York City. So this is a review data set, and I'm actually going to look at a subset of it, so about 10,000 entries, because it's a little bit computationally easier to handle. And this data set's got a lot in it. There's some textual information like the name of the listing, but we are really interested in the numerical information here. And so as before, we're going to pull out the numerical information. We're then going to drop the host ID. So the host ID basically should be random. There's a little bit of data cleaning that we have to do. There's some nans here, but basically the nans always correspond. So this is reviews per month and correspond to when the number of reviews is 0. So I'm pretty happy just filling them in with zeros. Okay, then we can go and check. And sure enough, we have clean data. Okay, so let's go back and do what was our first step before, and let's look at the correlation matrix. And okay, so here's the price, and here's our latitude, longitude, and other features. And what we see is that none of them really correlate. so this is an issue, and it's probably not. So there's some of these features where it's probably not an issue with the data, right? Minimum number of nights may just not correlate with the price. It may just be that, minimum number of nights tends to be 1, and that's that. But the one in, and I actually think that probably there's not much to say about any of these 5 in this case. But latitude and longitude is a little more confusing to me, right? Latitude and longitude, that is all of the spatial information about where these Airbnb listings are. That's whether they're near a park. That's whether they're near the beach. That's if they're in Brooklyn. That's if they're in the Bronx. All of this information should actually be highly correlative with the price if we can understand it correctly. And so, just taking a quick look at it in the scatter plot sense, what are we going to get? Well, we see a couple of things. So one, we see that we've got some outliers that we need to clean out, right? Most of the data is, there's 10,000 data points here, and this is about 10 of them. So we want to excise those in just a second. But the other thing that we see is that there is some structure to the data, some kind of blob-like structure that we're seeing here. And that's probably one of the reasons the correlation is so bad, right? Correlation is basically a linear measure, right? It's saying if you move up a little bit in latitude, the price goes up, or anti-correlation. If you move up a little bit in latitude, the price goes down. Here, the price seems to be going up as you move a little bit and then going down. So that's probably the reason the correlation is failing. So let's excise our data points above $1,000 a night. And we see even more structure. Still definitely not linear though. Okay, so it's a quick exercise. Let's take a look at the, just check and make sure that if we combine these 2 features together into a 2-dimensional data set and do a linear fit, that we don't get anything that interesting. And indeed, the R² is pretty low here. Okay, so what is interesting? The interesting thing is when we plot the latitude and longitude against each other. And all of a sudden, here's the city. We can actually use Matplotlib has a scatter library, which allows us to actually set the color based on the price. So we can actually visualize sort of three-dimensional information in 2 dimensions this way. Here, when I did this, I set this to be the log. And the reason is because there are still some very, very high prices. And if we color by just sort of a linear gradient between the lowest and highest prices, you see we lose a lot of information. It's still useful, and we can still sort of see where the higher priced areas are. But sometimes you want to look at a log scale just to get a bit of a clearer sense of the gradation there. Okay, so we see that there are some properties scattered about, but really the most expensive properties seem to be clustered in certain neighborhoods. And this is something that, again, this is just 2 columns of data, right? This is just 2 features, but because we know that there's extra information in there, we can see this very, very rich feature space. So let's just zoom into Manhattan for a second. So all I'm going to do here is I'm just going to cut out. So take longitude less than minus 43, latitude, sorry, 73.9, greater than 74. So we're just going to kind of cut out this portion of the map. Do the log scaling, and we can see here. We can see that the prices really don't seem to be distributed particularly randomly. Okay, so that's fine, and we can see that, and of course we have all the power of understanding some of the sociology and history and how how human movement happens, which neighborhoods are more expensive neighborhoods, which neighborhoods are cheap neighborhoods. So the question is, how do we take these 2 numbers and translate it into some feature-rich information that the computer can actually do statistics on. And we have to construct features. That's going to depend on making some choices. But one choice we can make, just as an example, and we'll talk about others, is we could, for instance, look at the distance between basically how close is the property to a train station, right? How close is the property to a subway station? I'm going to hypothesize that having the property be close to a subway station actually increases its property value. So how do we check this? So the first thing we're going to need to do is get a list of the latitudes and longitudes of the subway stations. Luckily, we can use the New York City Open Data Project. They've got all that information. The next thing we have to do is we need to figure out how to actually compute that distance, right? So the way that I'm going to choose to do it is, let's say that we have the jth property, right? And it's located at some longitude j, latitude j, right? We're going to construct this new feature by basically trying to figure out the distance from longitude j, latitude j to each of the possible subway stations. And then we'll just take the minimum. This isn't the most computationally efficient way we could do it, but for now, since we only have 10,000 data points, it's not too bad. Or actually less, since we're just in Manhattan. So given some stations, so we'll index the stations by I, then what we're going to call the metro distance is given by the minimum of all of the distances between xj and the station I, where we're taking the minimum over the index of the stations. And here distance is just the normal Euclidean distance, the sort of the hypotenuse of the triangle. So we'll dig into actually how to do this a little bit, but let's take a quick look at the result here. So running through all this, so we're going to download the information, do a little bit of string processing. Then we define a distance function, and we compute it for each of our for each of the latitudes and longitudes. And what we find is actually, not as great as maybe as we would like. And we can ask ourselves, well, is there a deep reason for that, or what's going on? And if we put the subway stations over our map of the prices, we can see that basically one of the issues is there's just subway stations all over New York, right? So okay, so this has not yielded a particularly good feature as far as what we're trying to do is find a linear correlation. So in a normal class, what we would do at this point, is say, okay, so we'll throw you guys into breakout rooms and come up with 3 possible features that you could construct out of the latitude and longitude data that would give us better indication of the price. And when you do this, when I say come up with, what I mean is state what it is, state what additional data you're going to need to get. And then say something about how you're going to actually compute it, right? It doesn't need to be quite as firm as giving the kind of equation that I had above, but you should at least say a few words about it. Okay, so this has been a demonstration of a more like lab style class, where this notebook would be available for them to play around with and to go along with. And then at this point, the assumption would be that they maybe play around with it a little bit more. If you want to take a look at this notebook, there's a link at the bottom of the page. And yeah, thank you very much for your time and have a fabulous afternoon.